What's going on, everybody? Chase with iDub Hockey, joined today with Brian Molnar, Senior Director of Engineering for True Hockey at True Timber Sports headquarters here in Memphis, Tennessee. And we're gonna talk about an advantage True has when it comes to building hockey sticks. Before we start talking about that, can you maybe just break down what it means to build a hockey stick, and then we'll get into some comparisons about how you do it differently.
Well, what sets us apart is our manufacturing process and the fact that we not only engineer the stick, the design, set the specs, set the design criteria, the design goals, we manufacture the sticks, so we're also engineering the process. So what does that mean? We got into hockey actually 24 years ago. We didn't launch True Hockey until 2014. But prior to that, we were a manufacturer for a lot of the other hockey stick companies out there. And when we got into manufacturing hockey sticks, we wanted a process that was built around hockey sticks. Companies that don't manufacture, they often go to different component suppliers, usually in Asia, and they're looking for a specific product to fit their process that they already have, right? So they're trying to shoehorn a hockey stick into an existing process. Usually they end up with a bladder molding process. So they're using an external mold. They usually start with a round shape. It may be rectangular, and then they're trying to inflate that part inside of a two-part mold. So that creates some inconsistencies with that process. Because you have a two-part mold, you lose some resin from your laminate when it's curing. It's just not the best process for a hockey stick. So our first step was to design a process for a hockey stick. We ended up with a compression mold process for the shaft. And what that means is we're actually wrapping material around a mandrel. We're fully constraining the material, and we pressurize at 250 PSI, which is a very high pressure. So we get very good laminate consolidation. All 25 of those layers of material are working as one after cure. There's very low void content. The more voids you have in the stick, the more likely you're gonna have a fracture or an early failure. So our shaft process is absolutely the best for a hockey stick. It's built for hockey, and we manufacture 100% of our own sticks in our own factory, and we also do it in North America. So it's a big competitive advantage for us. It's what allows us to have the lightest weight sticks on the market while still being durable for hockey. And then we also have a patented process where we co-mold the blade with that compression molded shaft. We're the only company that does that. So it's designing not only the stick, but the process, controlling all the manufacturing, building all the sticks in North America. That's really what makes us different.
And you mentioned about what you're able to do with the compression molding process in terms of maybe bladder molding or anything else out there, just to kind of give us a frame of reference, what's that pressure look like?
Depends on the supplier. I've been in a lot of factories over 26 years in hockey. I've seen it anywhere from 100 PSI up to 150 PSI. And typically, if you've ever broken one of our competitor sticks, particularly low in the shaft, you're gonna see like a little plastic bag in there. That's what they're using to get that pressure. They're inflating that bladder. That's why they call it bladder molding. They try to remove that bladder, but it usually gets stuck down here and tears, and they leave a little bit of material in there, which adds weight to your stick, which is not contributing to performance, durability, anything. It's just dead weight in the sticks. And they're very thin bladders as well. So a lot of times what happens is during the process, you might have a spec for 150 PSI. The bladder gets a little bit of a leak in it. It might drop to 80, 90. The stick comes out of the mold, it still looks okay. They just pass it to the next process. As a result, you get more inconsistencies in weight. Depending on your mold design, if you pinch any material out when you close that mold, you might get more resin bleeding out, which makes it more inconsistent in weight. We have the best weight consistency in the industry because we have a zero resin loss process. So we get very high quality material, very consistent weight. All of that material stays in the stick when we cure it.
You know exactly where it's going every time.
Exactly.
And then if I wanted to maybe compare a stick I have at home, is there a way I can maybe pop the end cap off? And is there any telltale signs that you can really look for in terms of consistency or inconsistency?
Yeah, you pop the end cap out, shine a light down there. Take your iPhone out, shine your light down there. You'll see we have very consistent wall thicknesses. It's mandrel wrapped, so we have very tight tolerances on our mandrels. The mandrel size combined with the laminate design is what gives us the external shape of the shaft. So everything's highly engineered. And like I said, it's all compression molded. Once this shaft is cured, it's ready to play with. It's ready for paint and graphics. There's nothing that needs to be done with it. The other process, you have a two-part mold, so you get resin running along the edge. They also use a chemical called a mold release, so the part doesn't stick to the mold. You have to go through some abrasive steps, sandblasting, sanding, to remove all that material, to remove that resin flash, and you're removing material from the stick. Our process is very simple, very high pressure, low void content, very little post-processing. Once it's cured, we co-mold the blade and it's ready for paint and decals.
And last but not least question here, just coming from my inner hockey gear nerd. When we talk about cold molding the blade to the shaft, how do those processes differ and how does True's kind of compare to that?
It varies across the industry. Pretty much today, everybody is making what we would call a true high-end stick, and that's, you could cure the shaft first and then cold mold the blade to the shaft. But what a one-piece stick is, there's no post bonding. The first one-piece sticks back 20 years ago, 25 years ago, you would make a blade, you would make a shaft, you would bond the two together with a structural epoxy, fill it in with some more epoxy, sand it, paint it, make it look like one piece.
Yeah.
But those two components were built separately from each other. So we're building a compression molded shaft and then cold molding the blade directly onto the shaft. So when our shaft is built, we're tapering the laminates off here. Our blade laminates come up at a very even rate. So if you were to cut this stick through this section, you'd see very consistent wall thicknesses all the way through into the blade.
Gotcha. There's no big joint between the two. It's nice and consistent.
No joint whatsoever, no.
Perfect. Well, Brian, thank you so much for having us out here and really detailing that true construction advantage.
No, thanks for coming.
And for you at home that want to check out the entire line of True hockey sticks, make sure you head over to icewarehouse.com.